Well, Tommaso, thank you very much for the introduction, and thank you very much for inviting me and give me the opportunity to present some work in progress. We hope that we are quite advanced now in our progress, but every time we present our work, there are new ideas. So let's get another round of discussion, and let's see how it can improve. So this is a paper that I've been working on with Despina Filiu, who's a former PhD student of mine and Derek Bosworth originally. And this paper is something that was not part of her PhD. It's something new that we are working on. And it is based on alliance data in biotechnology. And we are trying to try and understand what the patterns are in alliances when we take into account of the nature of partners. Okay, so to this audience, I don't need to convince or make a claim that alliances are important. Clearly, companies, firms need to assess knowledge. They engage in alliances to increase and speed up the process of creating new knowledge and new innovations. There has been a pattern over the last 20 years of increased alliances, and especially in some sectors, and biopharma is one of the sectors where alliance activities have been much bigger than other sectors. Telecoms is another one. But the observation also is that the evidence on the returns to alliances is very mixed. Not all alliances deliver in terms of innovation and new product development and so on. And not all firms are able to benefit from alliances. So why is that? What can explain the variety in innovation performance, innovation returns to innovation? So this is the starting question. The literature is quite vast now on alliances and also on biotech alliances. And one line of research emphasizes the role of learning and developing management, alliance management capabilities. So the more you engage in alliances, the better you are at it. So you know what are the issues that can raise, how to manage alliances, and so on. So that stream of literature on alliance capabilities is quite established. Maurizio Zollo has published a lot on that, Rotherman and Dietz, and so on. So that is quite established. Another line of research, or at least we are picking up another stream of research on the topology of partnership. So we know that if firms belong to an industry, they share some similarities, okay? Apart from the fact that they produce the same products, but what is behind the production processes is an understanding of the processes themselves. It means that they follow the same paradigms, mental frames. So it can be argued that industries represent clusters of firms that have a certain degree of similarity. So what happens if firms engage in alliances with firms in the same industry or with firms in other industries that will have a certain degree of dissimilarity? So that is what we are trying to bring in this research as an explanation of returns to innovation, the extent of similarities of partners. So there is literature also David Maury talked about the effect of similarity among partners on alliances. Knowledge transfer is easier. So we follow this literature. And some evidence is also about the fact that, well, we know new knowledge can emerge from combining different kinds of knowledge. And we do know ourselves, and when we collaborate with partners, we look for somebody who's not exactly like us, otherwise they replicate ourselves, but not so different, because then we don't communicate. And this is in a sense what Samson has found empirically, that some degree of a similarity is beneficial, but too low or too high similarity is less beneficial to creation of innovation. Okay. Then we also came, we thought of considering along this line of thinking also the idea of cognitive distance. That builds on this idea. And there is the work by Bart Nussbaum, especially that develops the concept of cognitive distance. And the argument is very similar. They also look at the role of absorptive capacity, which in a sense is about, well, if we share enough similar knowledge, we are able to make use of the knowledge of our partners. So if there is too much cognitive, too high cognitive distance, we may not benefit from collaborations and partnerships. So they use technological cognitive distance, they use the correlation, the average correlation with their partners of technological patent classes. So it's a very peculiar definition, but the underlying idea is about knowledge variation and absorptive capacity. And they found that there is a concave relationship between the cognitive distance and innovation. So the idea is always the same. Too low is not good enough because we know the same things, so we cannot create new knowledge. Too much means almost that we cannot communicate. There is not a good overlapping of knowledge. Somewhere in between is where collaborations and alliances can deliver innovation. We also justify some of the arguments in terms of complexity. If the technological distance, the cognitive distance becomes too high, there are also management issues. The complexity of managing these collaborations increases. There may be opportunistic behavior by partners. That is one of the reasons why often alliances are considered not to work, because partners tend to have a less trustful attitude. There is also a stream of literature. Rita Katila has developed. She uses a different terminology, but the underlying idea is very similar, because she and Gautam talk about the scale and scope of search, but then they use exactly same industry or different industry similarity. So in our literature review and the reading of all the literature in these areas, we find that sometimes the concepts are very similar, and the argument is quite strong about the role of partner similarity or cognitive distance. So we decided to elaborate some hypotheses on the basis of these ideas. We want to discriminate between intra-industry alliances, partners from the same industry, and inter-industry alliances. So, and what happens when the number of alliances increases? Okay, that is because the first argument in the literature is that companies, firms develop learning capabilities. So that clearly depends on the fact that they engage in more and more alliances. So we are trying to combine all these issues. The number of alliances increases. What happens? Do they have a learning capability? Do they develop learning capabilities? Well, it depends on the nature of partners. That is what our paper is about. So let's consider the case of intra-industry alliances. Firms from the same industry, they tend to have a similar knowledge. Okay. So what happens as the number of alliances increases? Well, the more you collaborate with somebody similar to you, the more likely it is that at some point you cannot think about many new things because you exhaust all the opportunities of creating new knowledge. You reach a sort of competency trap and a level of saturation. So after that point, as you engage in more alliances with partners from the same industry, the returns to innovation will decrease. So we mainly argue that there is an inverted U relationship between the number of intra-industry alliances and innovation returns. Okay. For the second hypothesis, we only have two hypotheses. We have tried we have sent this paper to a journal again already, and they want some revisions. So one reviewer especially pushed us to elaborate further on the second hypothesis, on the inter-industry alliances. So here we try to bring more arguments. We start from the idea that yes, inter-industry alliances may be more complex. They will lead to more knowledge, but they also increase the level of a complexity. As you expand the number of alliances, you will have to deal with more and more diverse partners, higher number of partners as well. So as the number of alliances increases, there is quite a lot of pressure to management for coordinating these alliances, to dedicate enough resources, and so on. We refer to the literature on limited bounded rationality, limited cognitive skills and abilities for firms, and therefore, if at the beginning of inter-industry alliances the returns to innovation are positive, as they expand in numbers, the returns will decrease. But then we can also think that at that point, managerial attention will start to come into play, and the managers may say, what's going on? Our returns to alliances are decreasing. What do we need to do? They will start to put more efforts. There is the literature, the idea of managerial attention that William Cashels developed that stems from the behavioral theory of the firm. And it is really about there is a point when managers need to attend these issues more carefully. There is the literature on learning capabilities, management capabilities, and again, there will be learning processes that help getting better returns. Part of some literature also argues that when companies are dealing with more heterogeneous partners, they need more control and governance structures that help reaping the benefits from these alliances. So there is some literature that can help us to understand, to argue that after a dip in the innovation performance, actually inter-industry alliances may deliver, again, some positive returns to innovation, some have a positive effect. And therefore, we argue that there is a U-shaped relationship between inter-industry alliances and innovation output. Okay. The learning, the hypothesis of organizational learning for one of the reviewer was just not enough. So we had to bring in all these other issues that in the paper we elaborate further, and I think they make a more convincing argument. So we, in a sense, we thank the reviewer. So the data that we use here. The data has been collected by Despina for her PhD, so she spent lots of time looking at the whole population of biotech companies in the UK between 1991 and 2001, and then she looked for all alliances that these companies have engaged in over the period of time. She used Recap and Bioscan, which are the conventional sources of data for the biotech industry and for alliances. We have, in total, there are 2,284 alliances in the sample, and we define intra-industry alliances as the number of alliances between partners that have the same 4-digit SIC code. Okay, so at a very low level of detail. And inter-industry alliances, firms that engage, alliances between partners that have the same SIC code at the first or second digit, but not beyond. Now, I can tell you we left out the partnership between partners at 3-digit levels, although somebody told us, well, you should put them with the intra-industry alliances. We tried both, okay, as a robustness check. And maybe you are more familiar with this analysis, I don't know, but or you have experience. What happens is that the results with when we put the 3-digit in this class are robust and they are conferred. When we put them here, they are also similar, slightly weaker, but they are the same. So because of this ambiguity, we took a more pragmatic approach and we left them out. That is something that in the past Giorgio Senigo told me. When you want to compare two groups, just take the extremes, and then you don't get messed up with middle groups issues. If you have other suggestions, they are very welcome. I'm tempted now to put them back here because of the number of observations, so it would increase the robustness of the results. In terms of innovation output, we use patents of these 110 firms coming from the UK Patent Office. We use controls. Alliance experience is there. It's the cumulative number of alliances over time with 1 year lag. We use firm size, investment in R&D, and we also use a dummy that controls for pharmaceutical companies and see if because the partner is in pharma, it leads to higher number of patents. Okay, now the statistical method. This is clearly a panel data set with a count data, patent data for the dependent variable. And the results are quite robust, to alternative models. Okay. The results I present today come from the Poisson fixed effect model with it's a version that Budrich has developed that corrects from standard error and that controls for over dispersion. Because the alternative, okay, the Poisson has the condition that mean and median are the same. This is not the case. If we over-disperse the data, you will need to use the negative binomial. We have used, the results are very similar. But because these controls for over dispersion, we use that model. But as I said, the results are very robust. Okay, some descriptive statistics and the correlations. The highest correlation here is between investment in R&D and firm size. It is not, we don't find any other stronger correlation between other dependent variables, other independent variables. And here are our results. Okay, so the first model is about intra-industry alliances, so companies from the same industry, where we said that there is an inverted U. An inverted U relationship. So we find that the linear term is weakly significant, and both in the model where we only test for hypothesis 1, and then it doesn't, it's not significant in the full model. Okay. That means that instead of having a U-shape, inverted U-shape effect, we have only the right side of the inverted U, because the linear term is 0. It's not significantly different from 0. So we are trying to explain this in our discussion. It means that actually there is no real learning effect. There is not the first increase in innovation output. Firms that engage in alliances start with a high returns to alliances, and then as they expand, they exhaust the knowledge space, the common knowledge space, and the returns to innovation decrease. So there is no learning effect. That is how we are trying to justify. Yeah.
What's the result if you don't have the square term?
I can't remember, probably because we just did the hypothesis and we did it this way. I can't remember. Because we have done that a long time ago.
Maybe usually if it's negative there.
Yeah. It could be if we only put the linear term, so in theory should be negative slope.
It is stronger than negative.
Yeah, we can try in the post-regression robustness check and the further checks. Yeah. For the inter-industry alliances, we find support for our hypothesis, which is something that we are pleased about, and the result maintains also in the full model. So we find something there that we can present. We were surprised not to find any effect of learning of the cumulative number of alliances. I was checking again. We don't have information on the duration of alliances. I remember in the past we tried to, because some paper, Rothenberg and this, for example, they do use the exact number of duration of alliances and accumulate that over time. So the alliance experience actually is weighted by, in a sense, the size and the importance of the alliance, but we do not have this information. We could use a weight system and try to introduce in the literature often they put that the average number of duration of alliances is 5 years. So we could use that, or simply to take into account of the decay of knowledge accumulated through alliances, and we can use the log. And so tried alternatives, they don't work. So somehow there is no learning effect on the number of alliances. And we don't find any effect on employees and R&D. And I don't know why we didn't put the pharma dummy here, but it's not. It's not significant in other models. So sorry, I put the models without that. Okay. So in our post-regression checks, we are trying to understand the actual shape of these curves. And about the intra-industry alliances, the minimum of this, the maximum, is 3.8 alliances. This is where the number of alliances, the curve starts declining. So we're trying to understand why is it that we have the first part, which is not significant, a linear part, and then the maximum is a 3.8. So we are trying to plot. That's what the refinements that we're working on right now. And we looked also some of our data here, and there are some companies that tend to have this kind of behavior in our sample. Shai Pharmaceutical and SmithKline-Beecham are two companies that have persistently engaged in a high number of alliances in the sample, sometimes only marginally, but they tend to have to reflect that kind of behavior. And about the second hypothesis, the inter-industry alliances, we find that the minimum number of alliances is actually 17, which is quite high. And that might put off lots of firms, because, I mean, if you have to engage in such a high number of alliances before you start getting some positive outcomes from alliances, it means that you really, if firms start incrementally with low numbers, it takes quite a lot of time before they start seeing positive returns. But again, when we looked at the studies using US data, these numbers are still quite low for UK companies compared to American biotech, US-based biotech companies. They tend to engage in many more alliances compared to UK companies. This is something that the reviewers have not argued. They didn't ask to explain better why there are these differences. Clearly, the national systems of these industries are different, but so we find that the number of alliances before companies need to will start to enjoy benefits, positive returns, is quite high here. So it means that the management of these companies need to realize that as they increase the number of alliances, especially inter-industry alliances, they need to put more effort. And they need to make sure that they are able to manage different partners, large portfolio of alliances with heterogeneous partners, that these kind of things don't happen on their own. And for alliances within the same industry, we have to find exactly what the curve is, but mainly, if it is an inverted U, it means that companies can benefit by expanding. They may be too low or too high, and they need to realize which one is the middle level, that is the one that gives the highest returns to innovation. And there may be other corporate strategy issues that determines why or whether a company firm will engage in alliances So clearly there are lots of limitations in this study. And one limitation that, again, we raised, and the reviewer said, yes, that is another study, is to look at firms that actually do both. Okay, because here we are treating them as two separate, if we want, strategies. But there will be firms that do both. And the learning, in fact, we assume that the learning may come from managing portfolios of alliances, not managing a specific portfolio of alliances with similar or dissimilar partners. But also because of the relatively low number of observations, at the moment we are keeping them separate because we want to make a stronger argument for our hypothesis. But I think that this is another interesting area that we want to investigate and see, is it better to have both? It relates a little bit to the exploration-exploitation dilemma. Do companies do better if they do more of the same, if they try and explore more and engage with dissimilar partners, or should they do a bit of both? Okay, so that is something that I wanted to investigate, probably in another paper. Usual stuff, this is a specific sector in a specific country. It would be interesting to see what happens in other sectors. There is some work that Bart Nuttbun and Massimo Colombo have published in GIBO, where they actually look at this relationship between cognitive distance and innovation, and they tested empirically in two different sectors, in biotech and in telecoms. So that was a nice example of when you present a study into different sectors in the same paper. And so that is something that could be done. We could do more about the patents. And clearly now it would be possible to weight patents, or if we could to see the citations of the patents and see really the value of patents, not just the numbers, or get other measures of innovation, if it was possible to distinguish between the extent of innovation. So one idea is that if inter-industry alliances are between partners that are more dissimilar, they are more likely to lead to more radical innovation. So that could be a line of argument. I'm not sure we can test this with this data, but I think that that could be the next step, not only to look at the diversity of partnership, but also the actual output, whether it varies depending on the nature of partners. So it could also be that there is a reverse causality, in the sense that if your returns to innovation from alliances are negative, that should reduce the probability of engaging in further alliances, or it may reduce the innovation output. Sorry, if the innovation output is low, then you engage less in alliances. So there could be other causality, reverse causality issues that can be analyzed. But I've learned, somebody early on in my career told me, one paper, one idea, one paper. So you cannot do everything in one paper. And so this is what we've done here. Thank you.